So we are going to have a look at accessing the command line right now. This chapter is really important because this is where we learn how you issue commands to your system, how you tell your system what to do. So to access the command line, we need a terminal emulator program. To access your terminal emulator, we click on Applications, we go into Favorites, and you can see we have a terminal program over there. So just click on that, and it will open up a terminal for you. I already have one opened up, so I'm just going to close it over there. And I want to talk to you about a couple of facts. First of all, your prompt is really important. The prompt is used for you to identify who you are logged on as. So if you see a $, it typically means that you're logged in as a normal user. And if you see a pound symbol or a hash symbol, it means that you are logged in as the administrative user. And in Linux, the administrative user is called root. Now, why this is important is because when you look at the Linux documentation on the internet or in other forms of literature, you may see that the command is prefixed by a $ symbol. And that means that that command is to be executed as a normal user. And if it is prefixed with a hash symbol or a pound symbol, it means that that command is to be executed as root. So what I'm going to do right now is that I'm going to exit out of my document. And I'm going to show you that we have the command line open up right now. So I am indeed logged in as the user student at my system, and this is the short name of my system. It's called Workstation. This is an indicator to my, my current location. So I'm currently located in my home directory. So that tilde key, the tilde key that you would typically find next to number 1 on your keyboard, that is an indicator that you are logged in as your home directory. It's the shortcut that represents the currently logged on user's home directory. And what we were just talking about right now, that $, that is the visual indicator that I am logged in as a normal user. And from here, I can go and execute commands. Like I can go and run the ls command. I can go and run the hostname command. I can go and run the date command as well. Now, a few things about the command line basics is that when you execute a command, it typically follows the notation, the command, the option, and then the argument. Now, sometimes these things may be completely optional. So I'm going to show you with the output of this command over here, ls-l/boot. So the command is ls. We are running a directory listing right now. -l tells us how we want to execute the command. Remember, the command is ls. And then the argument is /boot. So we are conducting the transaction against the directory called /boot. So as you can see over here, we have the command, we have the option, and we have the argument. So options come in two formats. We have the shortened version of the option, and we also have the long form of the option. Now, what you're looking at over here, this is the shortened form of the option. It's an abbreviated letter. So -L stands for long. And to indicate that we are using the abbreviated form of the option, we use a single dash. Now, when you make use of a double dash, you are telling the Linux command line that it is not to interpret every single letter in the word as an individual option. Now, let me show you this. I'm going to do an ls-a against /boot once again. Okay, so you can clearly quite see over there that I am using the shortened form of the option. And the A option is the abbreviation for all. So I'm looking at all files and directories in the directory boot. Okay, now check this out. I'm going to say ls-all. Now it looks like all, but I'm not using the abbreviated form of that particular command. What I'm telling the Linux, the Linux shell right now is that every single letter in the word all is to be interpreted as its own option. In other words, it's to interpret the A as one option, the L as another option, and that second L over there as yet another option. And look at the output right now. It's not the same output. So what I'm actually doing over there is saying ls-a for all, -L for long listing, and then I'm using the -L again, which is redundant. And we're doing this against the boot directory. Now, let me show you the longer format of that. I'm going to say ls-all. So what I'm telling the Linux kernel over there to do is that it must not interpret every single letter in that word as a separate option. Now, if you're wondering how I'm clearing my screen right now, I'm just using Control L, and that means to clear the screen. And if you want to disconnect from your terminal, if you want to close your terminal, you can either type in exit or you can use Control D. So right now, what I want to do is head off back to the terminal. So I'm going to go to Applications, Favorites, and we're going to open up the terminal program once again. And we're going to log into a remote system right now. I've got another system that I have set up called Server A. So to log into a remote system, I'm going to use SSH. SSH stands for Secure Shell. I'm going to open up a secure shell to a remote system, and I'm simply going to type in servera.lab.example.com. You can see that because this is the first time that I am connecting to the system, it's telling me that we couldn't verify that this is indeed the machine that you want to communicate with. We can't really identify that this is servera.lab.example.com. It tells me what the key fingerprint is of the remote system, and it asks me whether I want to continue connecting, whether I want to trust that this is indeed Server A. So I'm going to say yes. It now prompts me for Server A's password. So I type in my password, and this is the password for the student user. So what you can see over here is that I am logged in as student at Server A, and that I am a normal user. So let's disconnect from that remote shell. So I'm going to use Control D. So Control D always means exit or log out. It means the same thing. Now, if you want to connect as a completely separate user to the remote system, you could say SSH, specify that username, and then use an @ sign, and you can specify the remote system's name. So in this case, the @ sign is the separator between the username and the computer name. And now I have to type in root's password. And what I would like to show you right now is that I am indeed logged in as root at Server A, but this time you can see that we have that hash symbol, and that hash symbol is the visual indicator that you are indeed logged in as the root user. So I want to show you guys something really cool right now. I'm going to disconnect from Server A, and I'm returned to my workstation machine where I am logged in as the student user. So many systems, and for tighter security purposes, we avoid using passwords. So I'm going to show you guys how to set up SSH public and private key authentication so that I can log into the remote system. I can log into Server A without having to type in a password. And instead, I'm going to use another means of identification. That means of identification would be my private key. So the whole idea around this is that we're going to generate two keys. One is a private key, and as the name suggests, you keep that private. And we are going to generate a public key. And again, this public key is shareable. You can install it on another system. You can share it with other systems on the network as well. So we're going to take the public key, and we're going to store it onto Server A. And then whenever I try and log in as the user student at Server A, I will instead authenticate using my private key. That is going to be the means of identification that I'm going to make use of. Okay, so first up, I want to show you where your public and private keys are typically stored. And it's in a directory called .ssh. This directory is hidden, and you can see that I don't have any files over here that indicate to me that these are public and private keys. So to generate a key, the simplest way to do so would be to say ssh-keygen. And you can see that we have the default locations are indicated in brackets. So it says, all right, enter the file in which to save the key. This is your private key. So the private key is called ID_RSA. So let's go and accept the defaults. Do you want to secure your private key with a passphrase? No, I'm not going to do that right now. We're going to keep it simple. And you can see that it tells me that my identification has been saved in a file called ID_RSA, and again, that is my private key. Then I have my public key, which is that ID_RSA.pub, and that is the file that we're going to allocate to Server A. That is the file that we're going to copy over to Server A. So let me show you the before picture. I'm going to log in right now as the user student at servera.lab.example.com, and it prompts me for a password. Okay, that is the before picture. So allow me to disconnect from Server A. And now what I'm going to do is that I'm going to copy the public portion of my SSH public and private key pair. I'm going to copy the public portion over to servera.lab.example.com. Now, of course, in order to do so, I need to prove that I am indeed student. So I'm going to type in student's password, and there we go. So it says that the number of keys that were added were 1, and it suggests that we should now try logging into the machine with the command ssh and to servera.lab.example.com. Okay, so let's go and try that out right now. And here's your after picture. Now, you may think that I didn't authenticate because it didn't prompt me for my password. This is actually way more secure. My password didn't traverse the network. And because I'm in physical possession of that private key, that is how I prove my identity. And once again, I'm going to disconnect from server A, and I'm going to show you the contents of that .ssh directory. So what you can see over here is that that file over there is my private key. The public key ends in .pub, and these are the files that I need. I at least need the private key in order to authenticate to the remote system where my public key is installed.